The SpaceX Starship program is a thrilling showcase of the fail fast, learn faster mantra, where each rocket explosion is not just a setback, but a stepping stone toward groundbreaking innovation. Having mastered the Raptor engine's design through relentless experimentation, SpaceX has now set its sights on revolutionizing heat shield technology. Gone are the days of conventional ceramic shields. The company is boldly venturing into uncharted territory with cutting-edge metallic heat shields. But that's not all. These metallic marvels are designed to incorporate advanced technology to enhance system efficiency, something never before seen in the rocket industry. This daring leap not only redefines thermal protection, but also elevates rocket design to unprecedented heights. Find out everything in today's episode. Flight 6 marks a pivotal moment in SpaceX's journey toward Mars colonization, particularly the reusability of the upper stage. While some debates persist around Super Heavy's performance, the progress with ship was undeniable, which is what we see clearly the most in the thermal protection system. Following the Flight 5 launch of SpaceX's Starship, significant issues with the aluminum-coated heat shields were revealed. These shields, installed on both sides of the spacecraft, were unable to withstand the extreme temperatures experienced during re-entry. The aluminum melted, and the stainless steel hull showed discoloration due to thermal stress, confirming that the aluminum coating was inadequate for the intense heat conditions. Flight 6 was even harsher when the whole shield in certain areas on Ship 31 was removed, allowing SpaceX to push the boundaries of rocket design. As the vehicle descended, the world held its breath as witnessed something unprecedented. Portions of the spacecraft's surface transformed into a mesmerizing bluish hue. This suggests that the temperature in the tile-free zones exceeded 600 degrees Celsius, which is also the melting point of aluminum. This is the result of oxidation rather than just thermal discoloration, given that 304L stainless steel on Starship contains high chromium content, significant nickel, and extremely low carbon content. As the natural self-protective mechanism of the steel under heat, 304L stainless steel reacts with atmospheric oxygen, forming a chromium-rich oxide layer on its surface. This seems to be a particularly tense moment as the Starship team watched the thermal readings climb past expected thresholds. They had to make split-second decisions about whether to continue the experiment or abort. Fortunately, Starship made a safe landing in the Indian Ocean and remained intact despite the rough landing trajectory. SpaceX engineer Kate Tice said on the live stream for the event, "Turns out the vehicle had more capability than our calculations predicted, and that is why we test like we fly." However, after the launch, Elon Musk revealed a problem with TPS. The biggest technology challenge remaining for Starship is a fully and immediately reusable heat shield. This stems from his observation in all 6 tests. Ceramic used to be the sole option for SpaceX in producing Starbrick, and it eventually has become its Achilles heel. They're fragile, expensive to produce, and require extensive maintenance. So this is where the metallic tiles come in, representing a fundamental shift in how we think about spacecraft protection. Crafted from advanced alloys with extraordinarily high melting points, these shields offer unmatched durability and resilience. Unlike ceramic tiles, metallic shields can endure multiple re-entry cycles with minimal wear and tear, aligning perfectly with SpaceX's ambitious vision of creating a fully reusable spacecraft. However, for metallic heat shields to become a viable reality, SpaceX must tackle a critical engineering challenge: the effective thermal management of the shields. The development of these metallic shields hasn't been without its dramatic moments in its early testing in Flight 5. 6 aluminum-coated heat shield tiles on the ship's side melted during re-entry. Rather than considering it as a setback, the team leveraged these findings to improve the design with what's so-called liquid film cooling. Liquid film dissipates heat. Thus, the material actually becomes stronger under thermal stress. This could indeed be a promising new approach to addressing the challenges posed by the current heat shields. Liquid film cooling is a thermal protection technique that involves introducing a coolant fluid to form a thin layer over a surface to shield it from intense heat. Its mechanism of action is very simple. The coolant fluid is released through small holes or slots in the surface, known as film cooling holes. The fluid is directed along the walls to create a protective layer between the surface and the hot gas stream. Using tiny holes and liquid water or propellant to cool the surface has never been seriously proposed or tested before. While the general idea might have been thought of in the past 50 to 100 years, no significant research has been done on transpiration-cooled metallic heat shields. Metallic thermal protection systems themselves are already rare and largely untested in modern aerospace. Liquid film cooling is commonly used in the thermal protection of liquid rocket engines and hypersonic vehicles. An ideal coolant has high thermal capacity and low viscosity, is low-cost, non-toxic, chemically inert, and doesn't cause or promote corrosion. Water is a common and efficient coolant used in recirculating cooling systems, but in Starship's case, there is a little bit of change. Instead of using water, SpaceX chooses methane as the ideal coolant. Elon said, "When going to roughly 1750 Kelvin, specific heat is more important than the latent heat of vaporization, which is why cryogenic fuel is a slightly better choice than water." During re-entry, SpaceX's Starship faces extreme external temperatures that can reach up to 1,500 degrees Celsius. To manage this heat, the spacecraft employs innovative cooling techniques, including the use of water as a cooling fluid. This approach can lead to a surprising phenomenon known as snap freeze, which occurs under specific conditions. Snap freeze refers to the rapid transition of water from a liquid state to solid ice, often occurring when water is in a supercooled state. This process is well documented and involves several physical principles. When water evaporates at an extremely rapid rate, it absorbs a massive amount of heat from its surroundings. This is the latent heat of vaporization. The heat absorption is so intense that it can cause the remaining water to cool suddenly, freezing almost instantly. In harsh space conditions, especially within the narrow cooling channels of the heat shield, this can result in severe blockages, disrupting the entire cooling system. Anyway, before the innovation phase, SpaceX had already acquired basic knowledge about heat shields, thanks to what they learned from NASA's Space Shuttle program. The most notable thing is the similarities between Starship's heat shield and AETB, a material with a TUFI coating, and the addition of molybdenum disilicide, which was crucial in the final years of the Space Shuttle program. Indeed, examining Starship's tiles shows the complex presence, potentially of silica, alumina borosilicate, and aluminum oxide fibers, aligning with AETB. In fact, Elon Musk mentioned that the tiles are made from silicon and aluminum oxide. On the other hand, structurally, the Space Shuttle's heat shield tiles were known for their outer coating of tetrasilicide and borosilicate glass. Similarly, Starship's heat shield tiles have a distinctive black color. When you observe Starship during re-entry, you'll notice a beautiful blue glow of plasma surrounding it. This indicates that SpaceX likely uses a similar borosilicate coating, as borosilicate burns with a blue flame. Borosilicate is a type of glass containing boron trioxide, with a very low thermal expansion coefficient, meaning it's highly resistant to cracking or warping under sudden temperature changes, unlike regular glass. Nevertheless, according to SpaceX's CEO, the heat tiles on NASA's Space Shuttle are not actually a reusable orbital return heat shield in real meaning. With extreme effort, Starship will eventually take reusability to roughly 100%. There are many tough issues to solve with this vehicle, but the biggest remaining problem is making a reusable orbital return heat shield, which has never been done before. The shuttle's heat shield required over 6 months of refurbishment by a large team, so was not reusable by any reasonable definition of the word. Such a long time of refurbishment mainly stems from the shuttle's complex shape, meaning that most of its 24,000 tiles were unique in size and shape, making production, quality control, and refurbishment a logistical nightmare. The orbiter's TPS wasn't a simple system, but a collection of heat-resistant materials, each carefully selected for specific areas of the spacecraft. For instance, reinforced carbon-carbon, RCC, could withstand re-entry temperatures up to 1,260 degrees Celsius, protecting the nose and leading edges. High-temperature reusable surface insulation, HRSI, tiles made from Li900 silica ceramics with a heat-resistant coating were used on the underside where temperatures were lower. Felt reusable surface insulation, FRSI, provided protection for areas with temperatures below 371 degrees Celsius. In the past, the Space Shuttle's thermal protection system posed a significant challenge in terms of time and effort. With over 24,000 tiles, each varying in size by about 15 centimeters in length and between 2.5 to 12.7 centimeters in thickness, finding or producing an exact replacement tile for each specific area was incredibly time-consuming. NASA reported that just maintaining the TPS in the Orbiter Processing Facility, OPF, required up to 80,000 labor hours between flights, including QA inspections, repairs, re-waterproofing, and recertifying for flight. In contrast, Starship's TPS aims for a very optimistic turnaround time of about 1 hour and doesn't require such extensive labor. Starship's hull tiles are designed with nearly uniform size and thickness across the entire spacecraft. Only about over 100 tiles have unique shapes for specific areas like the nose and corners. While this might slightly increase the spacecraft's overall weight, it offers significant benefits in production, maintenance, and repair. This uniformity allows for thorough automation in manufacturing and quality control processes, resulting in simplified construction, shortened production times, significantly reduced costs, and higher reliability. This design also offers a strategic advantage for Mars exploration missions. The crew can carry spare tiles, allowing them to quickly and efficiently replace any damaged ones. This repair capability ensures the spacecraft's integrity for the journey back to Earth, significantly enhancing mission safety and success. This is a prime example of how simple design can yield enormous benefits in space exploration, embodying the philosophy of less complexity, more efficiency in modern aerospace engineering. Moreover, from Starship's Flight 5 onwards, SpaceX has focused more on upgrading the quality of Starship's heat tiles. Indeed, the company developed a new tile of heat shield that is twice as strong, or hopefully half as likely to crack or come off. They also added the ablative layers beneath the primary tiles as an insurance policy. These secondary tiles are made from silicone and felt, meaning they self-cool by slowly disintegrating to expel heat. Some specifics on the ablative material SpaceX plans to use have not been made public. However, Elon Musk has said that this material is not good for reuse, but keeps the ship and its inhabitants safe in case the tiles fall off during or before re-entry. Fast forward to Flight 6, SpaceX continues to push even further with new secondary thermal protection materials, and this signs a non-stop evolution in Starbrick's development. In the future, Musk has an even more ambitious plan to build an entirely new supply chain for low-cost, high-volume, and yet high-reliability heat shield tiles. In November 2012, Musk announced that SpaceX was working on methane-fueled rocket engines. This marked the birth of the most incredible piece of engineering in the history of rocket engines. That is the SpaceX's Raptor engine. The engine features a full-flow, staged combustion cycle for high efficiency and performance. It uses methane and liquid oxygen as propellants, offering cleaner burning and the potential for in-situ fuel production on Mars. With a thrust of 230 tons, it's designed for large-scale missions, including SpaceX's Starship project. The engine's high thrust-to-weight ratio, reusability, and advanced manufacturing make it a key innovation in rocket technology. To date, there are 3 known versions of the Raptor engine. The version designed for testing and development, Raptor 1. The second and more powerful and refined version, Raptor 2, is currently being used in test flights of Starship version 1. And finally, Raptor 3, which is a further upgrade with increased thrust, better efficiency, and more durability. It is expected to be used for Starship V2. At this point, you might ask, hey, where is this new engine you said they're planning on? Well, SpaceX has yet to officially announce any plans for another rocket engine. However, looking at what has been announced, the possibility that they are preparing an engine that is even more powerful than the current Raptor 3 is very high. First, let's look at the vehicle the Raptor engine will be installed in, the Starship. Designed to enable human missions to the Moon, Mars, and beyond. It is capable of carrying large payloads and crewed missions to low Earth orbit, the Moon, Mars, and deep space. Starship's reusability is a key feature, allowing rapid reflight and cost reduction for space travel. Ultimately, Starship aims to make space travel more affordable and enable the colonization of other planets. According to SpaceX's plan, there will be 3 versions of Starship. As mentioned, the latest Raptor engine under development will be used for the second version of Starship. So what about V3? At 150 meters tall, Starship V3 is much taller than previous versions, and its cargo capacity to orbit is also twice as high. This requires V3 to have a higher thrust. That is why further upgrades on engines might be made for specific needs in Starship V3, especially for interplanetary missions. Further evidence is that in his tweet, Elon Musk mentioned a future version that Elon calls Raptor 3.x. This new engine will have superior performance than the current Raptor 3 and get closer to the limits of known physics. Will this be a completely new Raptor 4 or an upgraded version of the Raptor 3? Either way, I can't help but be interested. So what capabilities will appear in this new version? To predict this, let's look at the improvements SpaceX has made over previous versions of Raptor engines. The initial version, Raptor 1, featured a revolutionary full-flow staged combustion cycle, which made it more efficient than traditional rocket engines. Before, full-flow staged combustion was still an experimental and niche technology in rocket propulsion, primarily due to its complexity and cost. With the successful test of Raptor 1, SpaceX has demonstrated that it can be a viable and beneficial approach for building powerful, reusable rocket engines for deep space exploration. However, Raptor 1 is still a prototype. After learning valuable lessons from Raptor 1, SpaceX created the next Raptor 2 version. The most obvious difference between Raptor 2 and Raptor 1 is that it has been simplified. The turbomachinery, chamber, nozzle, and electronics were all redesigned. Many flanges were converted to welds, while other parts were deleted. The elimination of engine parts helps to increase the engine's thrust-to-weight ratio. It also helps to increase the engine's fire resistance. On the other hand, removing parts requires extremely high precision in the engine during operation. Due to these changes, the engine's thrust was increased significantly. Raptor 1 can produce about 185 tons of thrust, which is already impressive since that's roughly the same as the RT-25 engine used in NASA's Space Shuttle and SLS. Meanwhile, Raptor 2 can operate at an even greater force, about 230 tons at sea level. In the case of Raptor 3, Elon simply took the advantages of the previous version and pushed them to the limit. First, the weight of this version is significantly reduced compared to previous versions. To achieve this, SpaceX engineers have significantly reduced the rocket's components. Elon, in an interview with Everyday Astronaut, said, "Bolts and flanges and seal of hell, especially if they're hot." So he wanted to minimize these parts as much as possible. The heat shield was also removed. Instead, the engine relies on regenerative cooling and high-temperature materials to withstand the extreme conditions of engine operation. According to Elon, this will save more than 10 tons of weight from the engine. Second, the thrust has been significantly improved. Raptor 3 can operate at a force of up to 280 tons force. Unlike Raptor 2, which sacrificed a small amount of specific impulse to achieve higher power, Raptor 3 achieves the same fuel efficiency as Raptor 1 at 350 seconds, while still producing overwhelming thrust. Looking at these changes, we can see a common thread. After each version, SpaceX tends to upgrade three main criteria: increase thrust, increase fuel efficiency, and reduce weight. So it is reasonable to predict that the next version of the Raptor engine will follow this path. Going back to Elon's tweet mentioned earlier, he gave a hint about the power of this new version. The Starship V3 plan will achieve an unprecedented thrust of up to 10,000 tons at sea level, significantly more powerful than any currently operational rocket, including the Saturn V, Falcon Heavy, and SLS. To meet this, each new Raptor engine will generate about 300 tons of thrust. That is nearly half the thrust of the F1 engine of the legendary Saturn V ship. The Saturn V's first stage was powered by only 5 F1 engines. Even so, was the most powerful rocket of its time. With 33 new Raptor engines, Starship V3 will be the most powerful rocket in history. Not only will the thrust increase, but Elon also mentioned that the thrust-to-mass ratio will surpass 200. This means that the engine generates 200 units of thrust, or each unit of engine mass, and further boosts the rocket's power performance. Another point worth noting is the engine's specific impulse. Specific impulse, usually abbreviated ISP, is a measure of how efficiently a reaction mass engine, such as a rocket using propellant, generates thrust. Specific impulse, measured in seconds, can be thought of as how many seconds 1 kilogram of fuel can produce 1 kilogram of thrust. A propulsion system with a higher specific impulse uses the mass of the propellant more efficiently. In the case of a rocket, this means less propellant is needed for a given delta V, so that the vehicle attached to the engine can more efficiently gain altitude and velocity. In simpler terms, the higher the specific impulse, the higher the fuel efficiency of the rocket. The Raptor 3.x will have about 5 seconds more PI than the Raptor 3. While that may not sound like much, in rocket science even a small improvement can have a significant impact on overall flight performance. To achieve this power, many parts of the engine will be modified. Although it is unclear what upgrades they can make after Raptor 3, Raptor 3 looks like it has been stripped down to the bare minimum to increase performance. However, one thing I can predict is that in this new version, SpaceX will try to remove as many 3D printed parts as possible from the engine. When the Raptor engine was first developed, 3D printing played a crucial role in building complex parts that were difficult or costly to produce using traditional methods. For instance, the Raptor's full-flow staged combustion cycle, which involves intricate components for fuel and oxidizer flow, has benefited from 3D printing techniques. As SpaceX moves towards mass-producing Raptor engines for the Starship program, they are looking to transition to more conventional manufacturing methods for some parts to improve speed and reduce costs. The goal is to scale up production of the Raptor engine as Starship aims for frequent high-volume launches. SpaceX wants to make the manufacturing process as efficient and cost-effective as possible, and reducing reliance on 3D printing in favor of more scalable techniques is part of that effort. With the 3.x engine, Elon intends to push it to the physical limits of what a combustion engine can achieve. This means that every element from materials to combustion dynamics must be utilized to its highest potential. The SpaceX Raptor engine is made from a variety of materials. including SX500 alloy, copper, aluminum, and steel alloys. These are strong materials that can withstand harsh environments and have high heat resistance, especially the SX500. A nickel alloy proprietary developed by SpaceX for use in the Raptor rocket engine. It's a variant of the Inconel alloy, which is a nickel-chromium-based superalloy that's often used in extreme environments. SX500 can withstand pressures of up to 12,000 pounds per square inch, equal to 830 bar, which is much higher than what conventional alloys can handle. This new engine will test the endurance of materials to the extreme. For Elon's vision of creating a vehicle that could travel at high speeds with minimal refurbishment, a highly durable engine was needed. Well, about that vehicle, there's one thing I haven't told you yet. There might be another way to get the thrust needed for Starship V3 without building a new engine. That's by increasing the number of engines. Even if SpaceX doesn't build a Raptor 4, the current Raptor 3 is still a beast. It outperforms other rocket engines like the RS-25 and RD-18 for its efficiency, greater thrust, and superior reusability, making it ideal for both orbital and interplanetary missions. So SpaceX can take advantage of this engine for the third version of Starship. Currently, the Starship upper stage, the spacecraft itself, is planned to be equipped with 6 Raptor engines, 3 sea-level engines and 3 vacuum-optimized engines. The Super Heavy booster, the first stage, is designed to use 33 Raptor engines. However, SpaceX has the flexibility to modify the number of engines if needed. Adding more engines could be done to increase thrust for heavier payloads or for specific missions requiring higher performance. According to an environmental impact report submitted by SpaceX for launching 44 Starship flights at Launch Complex 39, published by the Federal Aviation Administration in July, SpaceX proposed Starship launches configured with up to 35 Raptor engines for Super Heavy booster. There have been several theories about the rocket engine distribution of the 35-engine booster. One of them suggests that 2 additional engines will be added in the center. That would mean 5 gimbal engines in the center instead of 3. However, this idea has been met with opposition, with the counterargument that increasing the number of central engines would reduce the space needed for gimbal operations. Also, the ship balanced by the 3 center engines during the landing catch. 5 engines might not be able to throttle down enough. A more feasible option is that the 34 and 35 engines might be positioned symmetrically along the outer ring of the engines, while maintaining the core structure that SpaceX has developed so far. This will help increase thrust while still allowing for the 3 center engines with enough gimbal authority. Global military tensions are escalating by the day. On June 24th, a new study by RAND found that China's military over the past decade has become more willing to use risky, provocative behavior in space to forward its political objectives and less willing to communicate with the U.S. Defense Department and the Space Force even during a crisis. Further, to rationalize its move, Chinese leaders have inflated threat perceptions of the United States, viewing U.S. actions as aimed at maintaining global hegemony. Thus, they tend to interpret U.S.-led efforts to establish crisis communication mechanisms or broader space norms as tools to control China's behavior. In response to such aggressive actions, as usual, the U.S. military is forced to increase defense spending more than ever before and is expected to continue to increase. The U.S. defense budget has increased significantly since 2016, and in 2023 was $841.4 billion. This is a 62% increase since 1980 when adjusted for inflation. Also, the Pentagon is increasingly interested in a mega potential rocket for military applications, exploring the possibility of using the rocket for sensitive and potentially dangerous missions. It's SpaceX Starship. The giant rocket has recently made headlines with the success of 2 latest test flights, Flight 5 and 6. During Flight 5, Starship amazed the world by easily catching the Super Heavy booster with its giant Mechazilla structure. Flight 6, which took place just 37 days later, was considered a special flight because it saw the attendance of many high-profile figures, including President-elect Donald Trump. Another key presence at the event was General Chance Saltzman, the Chief of Space Operations for the U.S. Space Force, USSF. Saltzman watched the Starship launch alongside SpaceX founder Elon Musk, President-elect Donald Trump, and a number of lawmakers. A Space Force spokesperson confirmed Saltzman was invited by SpaceX to observe the test flight and participated in 2 days of program reviews. This highlights the Space Force's growing interest in the Starship program. In February, according to some sources, the DoD reached out to SpaceX to inquire about using Starship on its own, flying the massive rocket as a government-owned, government-operated asset on sensitive and potentially dangerous missions. Such missions would be used for transporting cargo or even personnel rapidly around the world. In addition, the Pentagon will likely utilize Starship to launch Starshield, the militarized version of the Starlink service. DoD currently buys Starlink's commercial internet service, but in the future, it also plans to acquire more than 100 Starshield satellites that would be government-owned. Beyond Starshield, there are other missions that require the Starship's massive payload, such as low-Earth orbiting weather spacecraft, intelligence systems, global communications capability, and elements of the new proliferated constellation. Such military launches rely exclusively on the Vandenberg West Coast spaceport, which is particularly advantageous for polar orbit launches and missions requiring trajectories that avoid populated areas. That means Starship could also launch in California in the future, but only on launches conducted by the government, not private companies like SpaceX. It has a point because California's regulatory framework is generally less favorable for commercial space operations compared to Florida. A typical example of this is SpaceX's plans to launch more rockets from the California coast, which is rejected by the California Coastal Commission. Although military officials argue that launches by SpaceX, a leading contractor at Vandenberg Space Force Base, should be considered a federal activity, commissioners in recent months have questioned whether SpaceX launches, which carry private Starlink equipment on up to 87% of their flights, should be considered private activity. So, with SpaceX's intention to launch Starship much more frequently, obviously, Cali is not the ideal location. On the other hand, the Pentagon launching its own Starship rocket could also bring some disadvantages besides advantages. On the plus side, once those Starship launches are conducted by the Pentagon at Vandenberg Space Force Base, which is federal property, it would not be hindered by federal agencies such as the FAA or state agencies like the California Coastal Commission. However, placing Starship under government control raises additional concerns. First and foremost, Starship needs a dedicated structure, Mechazilla, to launch and land, so the Pentagon would have to hire SpaceX to build another one in Cali. Either way, this isn't a big deal given SpaceX's rapid construction schedule. What's more important here is the technical challenges to control the vehicle. Starship's groundbreaking design and development are driven by SpaceX's team of exceptionally skilled engineers. A government-led program may not have access to the same expertise, potentially resulting in setbacks or failures. History provides a warning example. The U.S. Space Force once explored a Starship-inspired project called Rocket Cargo in 2021, but it was abandoned due to technological weaknesses and a government preference for the SLS program at the time. At present, the Space Force depends heavily on SpaceX's workhorse Falcon 9 and Falcon Heavy rockets for national security satellite launches. Therefore, the move to Starship shows the rocket's distinct advantages over existing vehicles. Starship is quite different from any rocket that has come before it. Once operational, its size, payload capacity, reusability, and the sheer number of vehicles planned for production will dwarf anything built over the past 70 years of space exploration. First, we must highlight Starship's capability for rapid transportation. The driving force behind this is the military's potential to use rockets to deliver supplies, and possibly even troops in the future, anywhere in the world in under an hour. Pentagon officials began considering this idea 2 decades ago, but it's only with the advent of Starship that this vision has come closer to reality. In 2020, the U.S. military command that oversees logistics operations signed an agreement with SpaceX and Exploration Architecture Corporation (XARC) to study the use of space launch vehicles to transport supplies in an emergency. Army General Stephen Lyons, commander of the U.S. Transportation Command, announced the agreement at a National Defense Transportation Association virtual conference on October 7, 2020. Think about moving the equivalent of a C-17 payload anywhere on the globe in less than an hour, Lyons said. The C-17 is a very large military cargo plane capable of transporting a 70-ton main battle tank. Envision a number of containers sitting in a warehouse down in Cape Canaveral. We go to an alert level. We pull them up, you start putting them on the rocket, said Gregory Spangers, chief scientist for the U.S. Air Force Research Lab. At each successive alert level, your time to launch shrinks and shrinks and shrinks, and we can get it down to 1 hour. Spangers said teams have already been making mock-ups of Starship's cargo bay, figuring out how to take advantage of a quick supply run. Speed is the obvious draw, but the cost is dropping and getting closer to existing expenses for moving supplies. The Starship/Super Heavy system will be fully reusable, unlike any rockets currently flying. The Super Heavy booster, similar to SpaceX's current Falcon 9 fleet, will return to the launch site. However, unlike the Falcon 9, Super Heavy can be caught by the launch tower, stacked onto a new Starship, refueled, and relaunched rapidly. Coupled with its design, Starship has significantly reduced costs for SpaceX. We may already know about SpaceX's current fleet of Falcon 9 rockets, with boosters initially designed for 10 flights, but advancements have shown they can potentially reach up to 40 flights. This reusability is a major factor in driving down launch costs. This innovation has driven launch costs down from approximately $4,500 per pound to around $900 per pound. Falcon 9 can carry between 44,000 pounds and 132,000 pounds. But Starship is a very different breed because it is fundamentally designed for rapid reusability. The vehicle is engineered from the start to fly 100 times, not just 10, and it will lift 220,000 to 250,000 pounds, 100 to 115 tons, into low Earth orbit. That number will increase as the vehicle evolves, possibly reaching more than 200 tons in the third version. The rocket will lower orbital costs to an initial $90 per pound, with Musk projecting this to drop to $9 per pound in the future. If achieved, this would make a single Starship launch cost less than 1,000th of NASA's closest equivalent rocket, the Space Launch System. This cost is nearly comparable to military supply missions using the C-17 transport aircraft, though Starship flights would take mere minutes instead of hours. Next is the launch frequency SpaceX has planned for Starship. SpaceX is on an ambitious trajectory to revolutionize space travel with its Starship program, aiming to build a vast fleet of up to 1,000 Starships in various configurations. Over the coming years, they plan to launch dozens, then hundreds, and ultimately thousands of Starships annually. To support this production rate, SpaceX has built its Star Factory at Starbase in Texas, which will add several 100,000 square feet of production space. This facility is designed specifically for the mass production of Starships, facilitating the company's long-term vision of making space travel more accessible. Currently, SpaceX has one operational launch tower at Starbase in Texas and is building an additional tower, Tower B. Furthermore, a new launch tower is being built at the Kennedy Space Center, KSC, in Florida, which will enable operational launches from both coasts. Frankly, the possibility of using SpaceX vehicles to move military cargo was mentioned in 2018 by the former commander of Air Mobility Command, General Carlton Everhart. "We've got to get at the speed of war. Mobility in space. What a concept. I need rapid access to space," he said. Back then, the Air Force said the SpaceX Big Falcon rocket would be one option to replace a C-5 mission. A C-5 aircraft can carry 150 tons of supplies to the other side of the globe in 10 hours, which is pretty impressive. But a rocket could launch a capsule that delivers the same amount in half an hour. In cases of extreme emergencies, for example, moving antidotes for toxic weapons, replacements for damaged gear, or a fresh load of ammunition, speed equals saved lives and successful missions. In theory, the U.S. could eventually create a network of pre-positioned supplies at spaceports, ready for quick packaging into a spacecraft. No doubt it's hard and difficult to launch a rocket. Rockets need to produce enough thrust to overcome the force of gravity pulling them down. This requires a lot of force, or escape velocity, which is about 3.5 million kilograms. 7.2 million pounds. Depending on the type and size of the rocket, there is a difference in power between them. For example, NASA's Deep Space Rocket, SLS, which is a super heavy lift launch vehicle, requires 8.8 million pounds of thrust. Its next generation, Block 2 configuration, will have a launch thrust of 9.4 million pounds and can lift to 101,000 pounds to deep space. The Saturn V is also a super heavy launch vehicle similar to the SLS with a maximum thrust of 7.6 million pounds. Fast forward to this century, and we have SpaceX's Falcon 9 medium lift rocket with a smaller thrust of more than 1.7 million pounds. When combining three of Falcon 9's core stages, the super heavy lift launch vehicle Falcon Heavy was formed with 5 million pounds of thrust at liftoff. Clearly, the modern Falcon Heavy is not as powerful as the traditional rocket, SLS. However, SpaceX has been developing a totally new type of rocket, a fully reusable Starship with size and power far superior to NASA's Orange rocket. The first version of Starship featured 16.5 million pounds of thrust, double that of SLS's Block 1. Nevertheless, everything always has two sides. Although the crazy power can benefit the payload capacity and deep space missions, it can simultaneously pose a threat to the ground infrastructure. A typical example is the case of Starship's maiden flight last April, when its immense heat and force at full display did significant damage to Starbase's orbital launch mount, blasting out a sizable crater beneath the structure and raining rocks and other debris down on the surrounding area. To handle this issue, in Flight 2 onwards, the water deluge system has been used beneath the launch pad, and it has demonstrated its great performance in protecting against the immense heat and force of Starship launch. After 6 Starship tests, SpaceX is now confident enough to apply the system to another rocket, the Falcon 9. Footage of the Falcon 9 landing confirms that SpaceX shared on X on December 5th that the engineers sprayed the deck with water before landing to reduce erosion. Does anybody know when they debuted this update to the drone ships? Perhaps after more than 300 rocket landings, the deck began to show signs of erosion, forcing the company to come up with the idea of a water deluge system. Or SpaceX has plans to increase the Falcon 9's launch rate even more in the coming years, and water could significantly extend the drone ship's lifespan. They have already installed the system recently. At this point, some people have raised interesting questions about this new system while waiting for an official answer from SpaceX. What type of water is being sprayed? Do we think that's seawater or an onboard supply of fresh water? Wouldn't seawater splashing up around the vehicle cause some corrosion or other problems? Almost all answers are towards the use of an endless source of seawater and steamed salt water. Due to the engine's exhaust, doesn't sound pretty bad. The steam itself would be pure water. That's how distillation works. However, if it splashes salt water around, it probably won't cause much of a negative impact because presumably Merlin engine bells are some stainless variety of steel. Some even worry that salt water might corrode the deck over time, but bear in mind that the deck does get pretty splashed with seawater on days with rougher seas, so it's not a matter. Some, on the other hand, suppose a drone ship can have an onboard water tank for remote firefighting. The capacity of that barge is pretty huge. It wouldn't be any big deal at all to carry thousands of gallons of fresh water in a tank below decks. You could top it up every time they go ashore to drop off the boosters. So how about you? Either seawater or freshwater? Please drop your idea in the comment. Anyway, SpaceX is so clever to utilize such a smart and safe technology to secure its ground infrastructure. The primary function of the system is to absorb and deflect the tremendous acoustic energy produced at liftoff. Rocket engines generate noise levels that can reach up to 180 decibels, creating shock waves as exhaust gases exceed the speed of sound. The water sprayed onto the launch pad helps mitigate this acoustic energy, protecting both the launch vehicle and its payloads from potential damage caused by these extreme sound levels. Furthermore, heat is also another nightmare. Rocket launches produce extreme heat that can damage concrete and steel structures. The water deluge system serves to cool the launch pad and surrounding infrastructure, preventing thermal damage. For instance, during a launch, approximately 700 cubic meters of water can be released to shield the launch table and other installations from the intense heat generated by rocket engines. In addition to cooling, the water deluge system also functions as a fire suppression mechanism. Saturating the area around the launch pad with water just before and during ignition reduces the risk of fire igniting from hot exhaust gases or other flammable materials present during a launch. This is particularly important given that rocket fuels are highly combustible. Along with footage of the drone ship being sprayed by water, the video also reveals a new record recently achieved by the Falcon 9. It's the 100th time a first-stage booster has landed on Just Read the Instructions drone ship, and SpaceX's 380th successful recovery overall. This is a part of a mission to launch the SXM-9 satellite on the morning of December 5th for Sirius XM satellite radio. The payload is the 10th spacecraft launched for Sirius XM, and the third of the company's satellites to ride a SpaceX Falcon 9 rocket to orbit. That mission marks the 19th flight for this particular booster, shortening the gap between it and SpaceX's most flown booster, which currently holds the record at 24 flights. SpaceX has 3 barges, 2 in Florida for launches from the Kennedy Space Center, and 1 in California for flights that lift off from the Vandenberg Space Force Base. The drone ships have rather creative names too. Of course, I Still Love You, Just Read the Instructions, and A Shortfall of Gravitas. The Just Read the Instructions drone ship didn't have the best start. It was first deployed on January 17, 2016, during the Falcon 9 flight for the Jason 3 mission. Although the booster managed to land on the drone ship, a problem with one of its landing legs caused it to tip over and explode. The drone ship was left a bit battered and a tad burned, but the damage was easily fixed, and Just Read the Instructions was able to sail again. The first successful landing for the vessel took place in January 2017 and marked the first successful booster recovery on a drone ship located in the Pacific Ocean. Just Read the Instructions was moved to Florida in December 2019, and since then has been used for missions launched from the East Coast. To date, the Of Course I Still Love You drone ship has hosted the greatest number of successful landings at 112, while A Shortfall of Gravitas has hosted 88. After a booster lands on one of SpaceX's drone ships, it's taken back to land where engineers check it over and refurbish it so that it can fly again. Early December also witnessed one of SpaceX's Falcon 9 boosters fly for a record 24th time. This method of reusing a booster instead of building a new one for every mission allows SpaceX to make its satellite deployment services more affordable and also cuts costs for NASA, which pays SpaceX for crew and cargo flights to the International Space Station. Following Falcon 9, SpaceX goes one step further by developing the next-generation Starship rocket. The vehicle was first mentioned in November 2005 under the name BFR, before SpaceX launched its first rocket, the Falcon 1. Later in 2012, Elon Musk first publicly announced plans to develop a rocket surpassing the capabilities of the existing Falcon 9. SpaceX called it the Mars Colonial Transporter, as the rocket was to transport humans to Mars and back. In 2016, the name was changed to Interplanetary Transport System, as the rocket was planned to travel beyond Mars as well. The design called for a carbon fiber structure, a mass in excess of 10,000 tons when fully fueled, and a payload of 300 tons to low Earth orbit while being fully reusable. By 2017, the concept was temporarily redubbed the BFR. In December 2018, the structural material was changed from carbon composites to stainless steel, marking the transition from the early design concepts of the Starship. Musk cited numerous reasons for the design change: low cost, ease of manufacture, increased strength of stainless steel at cryogenic temperatures, and ability to withstand high temperatures. In 2019, SpaceX began to refer to the entire vehicle as Starship, with the second stage being called Starship and the booster Super Heavy. They also announced that Starship would use reusable heat shield tiles similar to those of the Space Shuttle. The second stage design had also settled on 6 Raptor engines by 2019, 3 optimized for sea level and 3 optimized for vacuum. In 2019, SpaceX announced a change to the second stage's design, reducing the number of aft flaps from 3 to 2 to reduce weight. In March 2020, SpaceX released a Starship User's Guide, in which they stated the payload of Starship to low Earth orbit would be in excess of 100 tons, with a payload to GTO of 21 tons. At present, the mega rocket has experienced 6 testing flights with significant evolutions, most notably in Flight 5 and Flight 6. Flight 5, which occurred in October, was the most successful yet and featured an unbelievable moment as SpaceX performed the first ever catch of the Super Heavy booster by Mechazilla launch tower, enabling the reuse of a rocket. The primary objective of the 5th test flight was to attempt the first ever return to the launch site and catch the Super Heavy booster, and another Starship re-entry and landing burn, aiming for an on-target splashdown of Starship in the Indian Ocean. In Flight 6, SpaceX aims to repeat the same achievement, but eventually, no catch was attempted, due to a minor setback on the launch and catch tower. Chiefly, Starship completed another successful ascent, placing it on the expected trajectory. The ship successfully reignited a single Raptor engine while in space, demonstrating the capabilities required to conduct a ship deorbit burn before starting full orbital missions. It successfully made it through re-entry and executed a flip, landing burn, and soft splashdown in the Indian Ocean. Blue Origin's first orbital rocket, New Glenn, had an arduous journey to the launch pad. Named after John Glenn, the first American to orbit the Earth, New Glenn was developed before 2013 and was formally announced in 2016. By then, the public had raised hopes for the appearance of a third commercial heavy-lift rocket on the U.S. market, after SpaceX's Falcon Heavy and Starship vehicles. It would send another clear signal that the future of rocketry in the United States is commercially driven rather than government-led. Critically, New Glenn is also designed to have a fully reusable first stage, which will attempt a drone ship landing on its first flight. Unfortunately, BO's big rocket keeps disappointing with many delays, and this time, Blue continues to sow more hope about a maiden's launch in November 2024. In fact, they've already proven that the vehicle is on track by rolling it to the launch pad and lifting it vertically at Launch Complex 36. on the night of November 21. Moving the rocket to the launch site and raising it vertically is a key sign that the project is real and almost ready for a much-anticipated debut. Nevertheless, as we enter December 2024, the final month, the vehicle is still there. I mean, it's not flying yet. On December 5th, it took a new step forward by entering full-stack prop load tests overnight, and another round of testing as flare stacks are burning at LC-36, once again ahead of a potential static fire test. A static fire test of the first stage's 7 BE-4 engines is one of the final milestones before a launch. In addition to hardware readiness, regulatory approval is also a significant hurdle. It's literally on the pad now waiting for regulatory approval. It's waiting for its final regulatory approval to launch. So we're very, very close, Bezos said. That approval would be in the form of a Federal Aviation Administration launch license, which the agency has not yet issued. Bezos was not more specific about when the company would attempt a first launch, although executives have previously stated a goal of launching before the end of the year. So, at this point, can Blue Origin make orbit this year? Petit Frontier, who actively gave updates about space on its X account, estimates that Blue Origin's New Glenn is launching soon. The moment I know dates, I'm contacting the ISS to work out the orbits and photo potential with astronaut Petit. To add to the certainty, he confirms that he is one of the few humans on Earth with that privilege. And if the launch is visible, he will capture space history once more. Petit's news was reassuring to some. In reality, Blue Origin founder Jeff Bezos has been pushing the company hard to launch New Glenn for the first time this year, and the schedule is getting tight. Evidently, they already had to stand down from an October launch attempt and delay the launch of a small Mars-bound payload for NASA called Escapade. As Blue Origin nears the first launch of its New Glenn rocket, Jeff also shares a little bit about SpaceX's CEO, Elon Musk, and BO's path forward. Elon Musk has become the most talked name recently, after the win of Donald Trump. He was appointed head of the Department of Government Efficiency, followed by Jared Isaacman, nominated to be the next administrator of NASA. Furthermore, he previously asked Donald Trump to appoint SpaceX staff to top government roles in defense. Elon Musk and his allies' entry into key government posts certainly benefits a lot for SpaceX's business, which inherently dominates the market. This could concern its competitors, but Jeff Bezos. He said he is not worried Elon Musk's influence on the incoming Trump administration will adversely affect the company. In an on-stage interview at the New York Times DealBook Summit on December 4th, Bezos downplayed any concerns that Musk might use the current close relationship he has with the president-elect to give SpaceX an edge over competitors, like Blue Origin.
I take at face value what has been said, which is that, he is not going to use his political power to advantage his own companies or to disadvantage his competitors. I take that at face value. I could be wrong about that, but I think it could be true.
He even underscored his enthusiastic support for Musk by backing the so-called Department of Government Efficiency, a committee co-chaired by Musk and Vivek Ramaswamy that will study ways to cut federal spending and cut regulations. Besides praising Elon, Jeff didn't forget to praise SpaceX as, quote,
"Well, they're certainly very able competitors."
However, many people think that's not true. Blue Origin is not actually in the same league as SpaceX due to a yawning gap between them. The major defense contractor launches 350 missions using a flight-proven Falcon 9 rocket booster, delivers roughly 80% of all Earth payload mass to orbit in 2023, has 4 million Starlink subscribers worldwide, and is on track to reach the final frontier of rocket reusability, with developing the fully reusable Super Heavy Starship rocket. SpaceX obviously humiliates Blue Origin, who has yet to reach orbit. The only thing Jeff can brag about is New Shepard's suborbital missions, but as Neil deGrasse Tyson said, Blue is not really going to space. They're flying slightly higher than where planes go. They experience some weightlessness, but that is all. More comically, Jeff shows his childishness by conducting humorous legal maneuvers against SpaceX, which Musk calls Bezos, sarcastically, Sue Origin. On 13 August 2021, Blue Origin filed a complaint to the United States Court of Federal Claims about NASA's award of $2.9 billion to SpaceX. Bezos' space company has long opposed the development of SpaceX's Starship, arguing that NASA should favor its own lunar lander instead. Blue Origin has maintained that the massive spacecraft is too unwieldy and wastes too much fuel on its way to the moon. In the same year, Amazon-owned broadband satellite company Kuiper Systems also attempted to prevent SpaceX from expanding its Starlink constellation. At the time, Musk accused Bezos of retiring in order to pursue a full-time job filing lawsuits against SpaceX. On June 2024, the firm filed concerns to the FAA requesting that Starship's launch operations be potentially limited over environmental impact concerns. The filing focused on the FAA's intentions to prepare an environmental impact statement to evaluate the potential environmental impacts of issuing SpaceX a license to launch its Starship Super Heavy mega rocket from a launch pad in Cape Canaveral, Florida. Anyway, in an interview in 2023 with computer scientist and podcaster Lex Fridman, Jeff Bezos acknowledged Elon's talent and said,
Blue Origin needs to be much faster and...
Nevertheless, as you can see, nothing changed after that. The world's second wealthiest person continues to play tricks on his rival, and his rocket company still moves at a snail's pace. Given that, many raised a question. Is it true that Blue Origin is a rocket business, or it's simply a way for Jeff Bezos to call for attention? The firm's chief executive officer, David Limp, also asked Bezos whether Blue Origin is a hobby or a business. In the interview for the role last year, Bezos assured him that the company was a business.
Dave Limp, who you just hired to run Blue Origin for you as the CEO, said apparently when he was interviewing with you, he said, Jeff, is Blue Origin a hobby or a business?
Yeah.
What did you tell him?
It's a business. It's not a very good business yet.
Despite that, this man dares to set the ambitious goal that BO in the future could be bigger than his e-commerce giant.
I think it's going to be the best business that I've ever been involved in, but it's going to take a while.
So bigger than Amazon?
Yeah.
While there are no confirmed figures of Blue Origin's valuation, Amazon, which he founded in 1994, is worth more than $2 trillion. If Bezos is determined with his dream, Blue would need to go beyond that number, meaning more than 50 times SpaceX's current value. Musk's company is now reportedly seeking a tender offer that would value it at $350 billion, up from $210 billion earlier this year. It remains unclear whether Bezos gets the vapors, as that goal seems unlikely given BO's current state and SpaceX's breakneck pace of growth. We just know that Jeff appears to become more cautious in his words and actions in the upcoming Trump 2.0. It partly explains why Bezos showed unusual goodwill toward Trump and Elon Musk during a conversation on December 4th. He praised Trump's deregulatory agenda.
He seems to have a lot of energy around reducing regulation. And my point of view, if I can help him do that, I'm going to help him.
Bezos noted, arguing that doing so would help boost growth and solve some of the U.S. economic problems. Furthermore, he indicates his intention to engage with Trump on issues related to media relations. He hopes to persuade Trump to view the press as an ally rather than an enemy, and wants to meet with Trump to persuade him of that. The Washington Post had a strange move for the first time in decades, as it didn't publish an endorsement of a presidential candidate in 2024. Bezos reportedly intervened to block an endorsement of Kamala Harris that had already been drafted. This decision was viewed by many readers, Democrats, and some of the Post's own journalists as a transparent attempt to curry favor with Trump. Trump's disdain for the Washington Post has been well documented, as he often accused it of biased reporting against him. During the period surrounding Bezos's divorce announcement in January 2019, Trump took the opportunity to criticize both Bezos and the Washington Post. Trump referred to Bezos as Jeff Bozo in a tweet, mocking him amid the unfolding personal drama. So sorry to hear the news about Jeff Bozo being taken down by a competitor whose reporting, I understand, is far more accurate than the reporting in his lobbyist newspaper, the Amazon Washington Post, Trump wrote on X. Hopefully the paper will soon be placed in better and more responsible hands. His comments during Bezos's divorce were seen as part of a broader pattern of attacking media figures and outlets that he viewed as adversarial. The motivation behind Jeff Bezos's move to make peace with Trump is clear. During the Trump 1.0, there was significant speculation that President Donald Trump used his influence to derail a $10 billion Pentagon cloud contract that was awarded to Amazon Web Services. Amazon filed a lawsuit arguing that President Trump's personal animosity toward Jeff Bezos swayed the decision-making process. Despite losing the Worth contract, Amazon has since secured additional government contracts, indicating resilience in its business operations. However, concerns remain that a repeat of similar political dynamics could adversely impact its revenues and future opportunities. After lifting vertically at Launch Complex 36 on November 21st night, Blue Origin's New Glenn rocket once again raised hopes in the space community for its first launch this year. New Glenn was initially announced in September 2016, with an ambitious target for its first flight by 2020. Despite the initial enthusiasm, New Glenn faced multiple delays due to technical complexity, funding priorities, and shifts in strategy. The launch window was first pushed back to late 2021, then to the fourth quarter of 2022, and now with recent updates, a launch is anticipated before the end of 2024. While some space enthusiasts are skeptical about that launch window, the company has demonstrated its progress by saying that the rocket is literally on the pad, now waiting for regulatory approval. To add to the certainty, Christian Davenport, the reporter for the Washington Post, announces feasible that FAA grants approval for a December launch of the inaugural flight of New Glenn. But he is also a down-to-earth person, by reminds us that the launch date is tight. The FAA approval is within reach but not yet certain, as BO still faces some work ahead. He has a point because prior to launch, the New Glenn has to overcome an important rocket engine test, called the static fire test. We know that a static fire test of the first stage's 7 BE-4 engines is one of the final milestones before a launch. More importantly, as Blue Origin's CEO Dave Limp shared, this hot fire test also needs the FAA's green light besides the launch license approval, making matters much more complicated. Perhaps witnessing the launch is still a long way off. In the meantime, the vehicle's first stage, or GS-1, has been experiencing the chilling phase, or propellant loading test. This marks the first time they are tanking the first stage with liquefied natural gas, LNG, as fuel, and liquid oxygen, LOX. Then Dave added, the first stage LOX tank is nearly 30,000 cubic feet, and the LNG tank is almost 25,000 cubic feet, equivalent to about 24 and 20 tanker trucks respectively. GS-1 tanking during the NG-1 launch will only take about 30 minutes. Due to engine consumption during boost, it drains in just 3.5 minutes. If the granted license cannot be done in December, the next launch window could be January, the same time as SpaceX Starship Flight 7. Flight 7's updated timeline was disclosed in a NASA document submitted to the FAA. According to the report, a specially equipped aircraft will deploy to Perth, Australia on January 3, 2025, in preparation for Starship's Flight 7, targeted for January 11, 2025. NASA's mission is to observe Starship's re-entry and peak heating phases, with the spacecraft expected to splash down in the eastern Indian Ocean roughly an hour after launch. The document also highlights collaboration with Australia's Civil Aviation Safety Authority, CASA, which has agreed to honor FAA exemptions under the Melbourne Oceanic Centre's jurisdiction for this mission. While New Glenn's maiden launch is stuck on the ground, Starship's 7th launch is on track to launch early next year. Particularly its hardware, Booster 14, has already undergone a few critical tests. First of all, there is an igniter test on December 8th. An igniter test of a Starship booster is when SpaceX fires most or all of the Raptor engines at the same time to simulate their performance and ensure that no problems occur during launch. Another type of engine test that has also been conducted recently is a spin prime test, as the engines shoot out liquid oxygen to spin the pumps without ignition. Following the test, SpaceX is in readiness for a speculated static fire test during the next road closure, scheduled for Monday. A static fire test is a test in which the first stage engines are ignited, fired, but the vehicle does not launch. It remains static, hence static fire. It's safe to say that New Glenn's inaugural flight is a big matter not only for Blue Origin, but also for the space industry in general. Firstly, the New Glenn's inaugural flight will carry one of the company's new Blue Ring spacecraft on a National Security Space Launch Certification flight known as Dark Sky 1 and sponsored by the Defense Innovation Unit. Blue Ring's end-to-end services will seamlessly connect ground and space communications to support a variety of missions on orbit. The Dark Sky 1 mission will demonstrate Blue Origin's flight systems, including space-based processing capabilities, telemetry, tracking, and command hardware, and ground-based radiometric tracking. The lessons learned from this DS-1 mission will provide a leap forward for Blue Ring and its ability to provide greater access to multiple orbits, bringing the company closer to its vision of millions of people living and working in space for the benefit of Earth. The first launch's success will be proof of guarantee for the rocket's ability to launch NASA's Twin Escapade Mars Probe's mission, which is scheduled for spring 2025 at the earliest. Additionally, New Glenn should come online as soon as possible since it has contracts with entities like Eutelsat and Amazon's Project Kuiper for satellite launches, indicating a robust future launch manifest. The rocket's 7-meter fairing allows for the deployment of multiple satellites in a single launch, making it particularly attractive for companies looking to expand their satellite networks. For instance, AST SpaceMobile recently secured a multi-launch agreement with Blue Origin to deliver its next-generation Block 2 Bluebird satellites, essential for providing global cellular broadband coverage. This partnership underscores New Glenn's potential to support ambitious projects that aim to enhance connectivity worldwide. Like SpaceX, Blue Origin has been selected as a contender for the Pentagon's $5.6 billion National Security Space Launch Phase, 3 contracts along with SpaceX and United Launch Alliance. The contract is a big win for Blue Origin, marking the first time the space company founded by billionaire Jeff Bezos has been selected to launch sensitive national security satellites. SpaceX and ULA, a Boeing-Lockheed Martin joint venture, have had a lock on national security launch contracts under the Phase 2 program that began in 2020. Furthermore, BO has more ambitions for its big rocket, with the vision of millions of people living and working in space. For example, a reusable heavy-lift rocket will deliver heavy elements of a commercial space complex named Orbital Reef, developed by Blue Origin and Sierra Space. The 2 privately owned aerospace companies said they will work with Boeing, Redwire Space, Genesis Engineering, and Arizona State University to design, develop, build, and operate the Orbital Reef space station. It is architected as a mixed-use business park 250 miles above Earth for commerce, research, and tourism by the end of this decade. The station is being designed to support 10 persons in 830 cubic meters of volume. Also, some expect New Glenn's entry to compete with SpaceX's Falcon 9 and Falcon Heavy, potentially ushering in an era of industrialization and space exploration. Last but not least, New Glen's development and operation will play a vital role in national defense amid China's growing willingness to challenge the U.S. in space. The Vice Chief of Space Operations for the U.S. Space Force, General Michael Getline, issued a stark warning about China's accelerating advances in space technology and its growing capacity to challenge the United States' dominance in orbit. Speaking on December 7th at the Reagan National Defense Forum in Simi Valley, California, Getline described the evolving space environment as increasingly hostile, marked by the erosion of long-standing norms and the emergence of new threats to U.S. space assets. The adversary is quickly shrinking that gap, and we have got to change the way we approach space pretty rapidly, Getline said. Today, that capability gap is in our favor, but if it goes negative on us, it's going to be a really bad day. China's space ambitions have been well documented in recent years. Beijing has launched a record number of satellites and demonstrated technologies like satellite grappling arms and orbital debris removal systems, which could be repurposed as weapons. Its military space program has developed anti-satellite weapons, advanced satellite jammers, and other capabilities designed to disrupt U.S. satellites critical to navigation, communication, and missile defense. Experts say such capabilities could undermine the United States' ability to project power in a conflict. On November 30th, a Long March 12 carrier rocket successfully sent 2 experimental satellites into their planned orbits from Hainan Commercial Spacecraft Launch Site, China's first commercial spacecraft launch site in Wenchang, a coastal city in southern Hainan province. The mission marked both the maiden flight of the Long March 12 carrier rocket and the first launch mission of the commercial spacecraft launch site. In response, Getline emphasized that addressing the threat will require a fundamental shift in how the United States approaches space operations, especially given the Space Force's relatively modest budget and size. Key to this strategy, he said, will be closer collaboration with international allies and commercial industry, a break from Cold War-era thinking when the Pentagon was largely self-reliant. In the past, we didn't believe we could count on our commercial partners and international partners during times of crisis, Getline said. That has completely changed. Central to this new approach is the Space Force's proposed Commercial Augmentation Space Reserve, CASR program. Under CASR, private companies would contractually commit to providing satellite services to the military during emergencies, even if it means prioritizing military needs over commercial customers. Getline described this as a cost-effective way to ensure access to critical space capabilities during crises. We're trying, with very limited resources, to get after an enormous demand signal coming out of our joint force, he said. However, the program has yet to award contracts, and details about its funding and scope remain unclear. Representative Rob Whitman, who also spoke at the Reagan Forum, expressed strong support for CASR, emphasizing its importance in leveraging commercial and allied capabilities to maintain a strategic edge. It shouldn't just be about satellite services, Whitman said. We have to make sure it includes launch vehicles. We have to make sure that our reserve is there to where, if called upon tomorrow, we could respond at the speed of relevance. Whitman urged the Space Force to ensure the program is comprehensive and prepared to respond to threats swiftly. He said the urgency is compounded by China's growing willingness to challenge the U.S. in space. Getline's warning comes as the Space Force continues to advocate for more funding and resources to address these threats. We must act now to ensure that the capability gap doesn't shrink to zero, or worse, go negative, Getline said. And that just about wraps it up for today's episode. Thank you, and we look forward to seeing you next time.